Hello, welcome back to the video for lesson 4.2. And chapter 4.1, we looked at where two linear equations either intersect at one point, no points, or every point on the line. And now we're going to add in a third equation to see what can happen. And this would be in a graph, it would be more like a 3D space. So there could be a couple different outcomes. There could be they intersect at a triple, which is just a single point. They could intersect at a line, which would be a plane, would be all 3 points. You can see the pictures in the book. So let's look at how we do this algebraically, and I'm going to show you in Desmos how to check your work. So we're going to try to eliminate one of the variables, but we have to do that out of two of the equations so that we get just two equations in that one variable and then eliminate it out of all three equations. So for instance, I can see that y is already opposite signs in row 1 and row 2, and then compared to row 1 and row 3. So I am going to eliminate y by adding row 1 and row 2. And I'm creating a new row, and I'm calling that row 4. So that will be 2x, my y's cancel, and then I have a negative z equals 5. I'm going to write row 4 over here. 2x minus z equals 5. Then I'm also going to add row 1 to row 3, and I'm creating row 5. So x minus y minus 2z equals a negative 1, and x plus y minus z equals 4. So again, my y's cancel. I have 2x minus 3z equals 3. That's my row 5. So I'm going to write row 5 over here. 2x minus 3z equals 3. So now I need to eliminate x or z. So I'm going to choose to eliminate x because they are both 2's. And I just have to make one of them negative. So I'm going to take the negative of row 4. So it's going to be negative plus negative. And then I can add them. And I'll get a negative 2z equals a negative 2. And dividing by a negative 2, we get z equals 1. Then we take z equals 1 and put it back into either row 4 or row 5 to solve for x. So I'm going to choose row 4. I put 1 in for z. So x equals 3. And now I know that x equals 3 and z equals 1, and I can put that back into rows 1, 2, or 3. So I'm going to put that into row 1. Both of those. So x is 3 minus y minus 2 times z is 1 equals a negative 1. So 3 minus y minus 2 equals a negative 1. Minus y plus 1 equals a negative 1. Minus y, subtracting 1 is a negative 2, and taking the opposite, y equals 2. So my ordered triple is 3, 2, 1 for x, y, and z. Now, if you click on my Desmos link, I'm going to show you how this works. It's a little bit quirkier here. So you can see I've got the 3 equations in. And I'm going to show them. So, okay. So here are my three equations. The black one is my first equation. The blue is my second equation, and the Z is my third equation. And right now it doesn't look like they look at equal at all. So you need to let Desmos create a slider, or if you just save this file in your own Desmos, you can go back to it during the test because I put the link that you can access your own Desmos. You can go back to this, hopefully you can go back to this file. If not, it should automatically ask you to create a slider for Z. And then when I move it, see what happens is they get closer together. So I'm going to move this until they intersect. And I believe for my equation solving that they intersect when Z equals 1. And you can see that here where I'm circling with my mouse, it is when Z equals 1 that they actually collapse. And that is where they intersect. And you can see that X is 3 and Y is 2 at that same point. Pretty cool. So let's see another one. Let's go back to our paper and look at letter B. We have these three rows, row 1, 2, and 3. And it looks like my Y's can cancel again. So I'm going to add row 1 to row 3. And then that's going to create row 4 again. So the Y's cancel. I've got 2x plus 3z equals a negative 7. And then I'm also going to do row 2 with row 3. So x plus y minus z equals 6, and x minus y plus 2z equals a negative 7. So the y's eliminate. I've got 2x plus z equals a negative 1. So row 5 is 2x plus z equals a negative 1. Now, my row 4 and 5, you can see that the x's are the same coefficient but opposite signs. So I'm going to just take the negative of row 5, negative, and that'll be a positive now. So my x's eliminate. I have 3z minus z is 2z. A negative 7 plus 1 is a negative 6. Divided by 2, I get z is a negative 3. I'm going to put that back into row 4. So 2x plus 3 times a negative 3 equals a negative 7. 2x minus 9 equals a negative 7. Adding 9, 2x equals 2, x equals 1. And then they're both going to go into row 1 to keep it easy. So x is 1 plus y plus z is a negative 3 equals 0. So y minus 2 is 0. So y equals 2. So it looks like my ordered triple is 1, 2, and a negative 3. Let's go to Desmos and check it out. Here are my 3 lines that I'm looking at, and I'm going to use my same slider. That's the cool thing. Once you've got the slider, you can use the same one. And I'm moving it to where I think z is a negative 3 this time. There it is. And then I can click on one of the lines and it will tell me the x and y are 1 and 2. So it's pretty cool. I want you to do this on the test. There's going to be a problem, I believe, that I have a system of 3 linear equations, and I want you to go to Desmos. I want you to find that intersection point for X, Y, and Z, and then you're gonna work backwards to solve your system. Let's look at letter C next. These three equations here. And none of them are super easy. It looks like 4 and 6 are both multiples of X of 12. I think that might be the easiest one. And okay, so I'm gonna eliminate X to a multiple of 12. So that means I'm gonna do 3 times row 1. It's gonna give me 12X plus 18Y minus 24Z equals 3. And then I'm going to do a negative 12 to row 3. So a negative 12X plus 24Y plus 24Z equals 36. So the row 4, when my X's eliminate, is going to be 42Y. Oh, and my Z's eliminate, and I get 39. Okay. So that means I can solve for Y and reduce by 3, and I get 13 over 14. 13 over 14. Okay. So I'm going to do 3 row 1 like I did before. So that's just 12X. Oh, no. Yeah. Plus 18Y minus 24Z equals 3. And then to get to this, I'm going to do 2 times row 2, and it'll be a negative 12X, negative 18Y plus 24Z equals 0. And my X's eliminate, oopsie, my Y's eliminate, oopsie, and my Z's eliminate, and I get 0 equals 3, which is not true. So it appears that they are inconsistent because that's not true. So let's go to, let's just write that down on our paper here. Inconsistent. Back to decimals and check this out. I'm going to put new equations in here. So 4x plus 6y minus 8z equals 1. And then we have a negative 6x minus 9y plus 12z equals 0. Next one is okay. I think I got this mixed up now and corrected. And we have the last one is x minus 2y minus 2z equals 3. Okay. 4x plus 6y minus 8z equals 1 minus 6x minus 9 plus 12 equals 0. Okay. So I think what happens is I move the slider and I can never get them all to equal. And it's because these two lines are parallel. It looks like row 1 and row 2 are parallel to each other by 1.5. And so they're inconsistent. We have one last problem here. If you look at your paper, flip it over. It's example 2. It's a word problem, so that's always fun. So it says the sum of 3 numbers is 14. Okay, I'm just gonna, not knowing anything, I'm gonna call them x plus y plus z is 14. Okay, there's my row 1. The largest number is 4 times the smallest. Okay, so I'm gonna say x is the largest number, okay? I'm gonna let x be largest. And it's 4 times the smallest. I'm gonna say z is the smallest. While the sum of the smallest and twice the largest is 18. Okay, so if z is the smallest, it says the sum, so I'm adding the largest number is 4 times the smallest. Okay, while the sum of the smallest, z, and twice the largest, x, is 18. Use the linear system in 3 variables. Okay, so I'm going to write this equation up here as the largest is 4 times the smallest. So we don't know anything about the middle number, y, but we know that x is 4z. I mean, the z plus 2x is 18. Okay, so let's write this without y in there. So in this one, we know we have z 2x plus 0y. And then we know x minus or plus 0y minus 4z equals 0. Okay. So what could we, let's eliminate z from all of these because we have one negative, so we just have to multiply row 1 and row 2 by 4. So I'm going to do 4 times row 1 plus row 3. Okay, so it's going to be 4x plus 4y plus 4z equals 56. And then I have x plus 0y minus 4z equals 0. So my z's do eliminate. And then I have 5x plus 4y equals 56 is my row 4. Okay. And then I'm going to do the same with row 2. 4 times row 2. So it's going to be 8x plus 0y plus 4z equals 72. And then row 3 is x plus 0y minus 4z equals 0. So I have 9x, my y's eliminate, my z's eliminate, and I have 72. So x equals 8. That's pretty cool. I eliminated 2 there. So x equals 8. And then I can put x equals to 8 into row 4. So 5 times 8 plus 4y equals 56. So 40 plus 4y equals 56. And so if I subtract 40, I get 4y equals 16. And divide by 4, I get y equals 4. So now I know y and x. I just need to know Z. And Z, X is 4 times Z, or I could also use this one up here, Z plus 2X equals 18. I'm gonna use that one. So Z plus 2X equals 18. So Z plus 2 times 8 equals 18. Z plus 16 equals 18. So Z equals 2. So the interval is 8, 4, and 2. And they do add to make 14. So that is the first equation, right? They add to make 14. And X is 4 times Z. So X is 4 times Z. And then Z plus 2 times X equals 18. So that works. 8, 4, and 2. Excellent. Catch me back for lesson 4.3. It's all little story problems with solving systems equations.